Hi students, welcome. In this video, we'll see the problem based on continuity equation for header pipe and branch pipe. So students, see here, a 500 mm diameter pipe carrying water at rate of 0.5 meter cube per second branches into two pipes of 200 mm and 400 mm diameters. Okay, if the rate of flow of water through the small diameter pipe is 0.2 meter cube per second, determine the velocity of flow in each pipe. Okay, so now let first we will draw the diagram for this particular problem. So here see, our header pipe is 500 mm have 500 mm diameter. So this is our header pipe, okay, of having 500 mm diameter. Okay, and this 500 mm diameter pipe is branched into two pipe another pipes. This is one pipe, okay, and this is another pipe. Okay okay this pipe has diameter 200 mm. This is small pipe, 200 mm diameter, and big this pipe has diameter 400 mm. Okay, this is the flow direction of the fluid. Okay, here we have q, and this q is divided into, suppose this is our one pipe number 1, this is our pipe number 2. Here we have flow q1, here we have flow q2. Okay, and we have given the velocity of, sorry, we have given the flow rate, okay, that is q of the 500 mm diameter pipe is 0.5 meter cube per second. So here we have q 0.5 meter cube per second. Okay, and further we have given the small diameter pipe flow volumetric flow rate is 0.2 meter cube per second. So small diameter pipe is our this one. So here we have 0.2 meter cube per second flow rate, that is volumetric flow rate. Okay, so now from this given data we have to calculate the velocity of flow in each pipe. Okay, so for here we will apply the continuity equation. So here by continuity equation, we have here q is equal to q1 plus q2. Okay, so here we have q, value of q is 0.5 meter cube per second, and volume value of q1 is 0.2 meter cube per second plus q2. So from that we can calculate the q2. Here q2 is equal to 0.5 minus 0.2, which is equal to 0.3 meter cube per second. Okay, we have calculated here this q2. Okay, so we got here first value of q2. Okay, now as we know, we can simplify this equation, as here we know that this is continuity equation. So we can write down this equation as a v is equal to a1 b1 is equal, sorry, plus a2 v2. Okay, as we know here, flow rate, that is q, is given by area into velocity. Okay, so now we will take one by one. Here we will calculate the velocity. For that, first we will calculate the here velocity of this bigger pipe, that is 500 diameter pipe. So for that, here we have now Q is equal to AB, which is we can write down as V is equal to Q upon A. Okay, so now we will put the values in this equation. So here we have now V, that is velocity, is equal to Q. We have here 0.5 meter cube per second, and area we need to calculate. For that, we have here equation pi by 4 into d square. Okay, so here we have value 0.5 upon this 4 will go up here 4, okay, into pi into d is we have here 500 that is 0.5 meter. 500 is equal to 0.5 meter. Okay, so that's why here 0.5 square. From that, now we will calculate the velocity. So now calculating the velocity, I am using here the calc. So here we have 0.5 into 4 upon here we have pi into 0.5 square. Okay, so here we have got 2.55 here meter per second velocity. So here we have 0 point, sorry, 2.5. We got answer here 2.55 meter per second velocity. Okay, this is our first answer. Okay, now similarly we will calculate the velocity for other pipe diameters. Okay, so after calculating the values for V1 and V2 by using the same method, we got here V1 is equal to 6.37 meter per second and V2 is equal to 2.39 meter per second. Okay, so students, in this video we have understood the problem based on continuity equation for header pipe and branch pipe. Thank you students for watching this video. Like, share and comment for this video and subscribe my channel. Thank you.